All right, so we're on to tile pattern 3. This is in lesson 113. And what you'll notice here is the first figure has 3 tiles, and then it doubles, and then it doubles. And then down here for the last figure, this 4 wide is now 8 wide. There's a second pattern going on where there's 1 square, and now it doubles to 2 squares, and now it doubles to 4 squares, and then it doubles to 8 squares. So each new pattern, first I got 1, 2, 3, 4, and then I got 2, 4, 6, 8. So I got plus 4, plus 8, plus 16. So when we're looking here and we're trying to come up with pattern 3, we went from 4 tiles to 8 tiles to 16 tiles to 32 tiles. We were always adding the same number. 4 plus 4 is 8. 8 plus 8 is 16. 16 plus 16 is 32. That means, we could describe it that way, but we can also just say multiply the previous number of tiles by 2. That's another way to name the pattern, a little more efficient anyway. And because we started with 4, the pattern actually starts with 4. And then because we're doubling, it's 2 to the x power. That's what happens when you double, and you get this curve. It's exponential because you're doubling. You get an exponential curve. We've also got tile pattern 4 to look at. Tile pattern 4, at 0, it's undefined, meaning when x is 0, we have no idea how high y can go. So we really don't even use that very much. We would start here at figure 1, which has 48 tiles, and then figure 2 only has 24 tiles. So you'll notice that's half. 24 goes down to 16. Not half, but 2/3. So here we went 1, 2, 3, 4, 5, 6 rows down to only 3 rows. Well, then we went 3 rows down to only 2 rows. That's where I'm getting the 2/3. And then we went 2 rows down to only 1.5 rows. That's 3/4. You'll notice we lost 1/4 of the height here compared to the one before it. So this one's a little trickier. It is a decrease, an exponential decrease. So it's going down with a curve. So if we want to describe this one, we'd say starting with figure 1, because remember, we didn't start with 0. Starting with figure 1, multiply the previous number of tiles by 1/2, and then 2/3, and then 3/4, and so on. So the next one would be 4/5. All right, and then if we flip this over, we've looked at all 4 patterns. Let's specifically talk about pattern 2. So pattern 2, you'll remember we went +1, +3, +5, and we were increasing the amount of increase. It was a curve. What is the general shape of the graph? Okay, so we're like, that's no problem. That was a curve, and it was increasing. If you drew a line or curve through the points and extended it in both directions, what would be the x and y intercepts? Well, we can see that the y-intercept is 0, 4. And it doesn't have an x-intercept because you'd have to go into one of the negative quadrants, and we can't do that with tiles. We don't count negative tiles. Are there any values of x or y where it's not possible? So x has to be greater than or equal to 0. And y must be greater than or equal to 4. Those are our cutoffs. Describe tile pattern 3. Okay, so we just looked at tile pattern 3. This was the newest set on this video. This was first. It's definitely a curve, and it's definitely increasing from left to right. Also starts at 0, 4. X must be 0 or greater, y must be 4 or greater. So all of the descriptors actually stay the same for tile patterns 2 and 3. We said it was a curve. We said it was increasing. And 0, 4 is the y-intercept. And are there any values? X had to be greater than or equal to 0. And y had to be greater than or equal to 4. So kind of funny that they are 2 very different tile patterns, once you get into them, but they have the same set of general descriptors. Then we've got describe graph 4. So 4 is going to be this one, which is different because we'll notice it's decreasing. Also had that kind of funky start to it where figure number 0 was undefined. So general shape of the graph, curve. But because it was that one going down to the right, we would say it's inverse. We talked about that in a previous lesson. Decreasing. And this one happens to have no intercepts because 0 is undefined. And then if we kept going to the right and it kept getting smaller and smaller and we took a fraction of a fraction of a fraction, it would get closer and closer and closer to the x-axis, but never actually touch the x-axis. So this one has no intercepts. Are there any values of x or y which are not possible in the function? So x must be greater than or equal to 1. Because we didn't have a 0. And y will approach 0, but never be 0. So y approaches 0. All right. Write a list of questions to ask yourself when fully describing a graph. So what are some things that you should consider? What additional questions can you think of? So I actually wrote down a few here. First one I've got on there is it discrete or is it continuous? And this is something to talk about. Is it discrete? Do I only draw the dots, or is it continuous where I connect the dots with a curve? So discrete, you wouldn't have those fractions and decimals. This is things that you can count, like counting on your fingers. Continuous is something that you measure, things that have, a fraction of an inch or, tenths of a second, things like that. Does the graph have symmetry? Is there a symmetry? Does it curve to a point where it goes down and comes back up again? Does the graph have any sort of maximum or minimum? Those are other things to consider, especially if you had a curve, like thinking about water coming out of a water fountain and it goes up and then comes back down. It would have a maximum height. Is there an end point? Is there a place where the data stops, where you stop collecting information? And does y grow faster or slower in parts? Another possible question, does your graph change its slope? Does it start getting faster and faster and faster, or does it just start to slow down? There's a number of options in addition to these, but these were just a few that I had come up with.